Hi, so we're going to take a look at setting up the camera for and getting facial recognition running on a Raspberry Pi. So let's go ahead and get started. I'm going to be looking at the Raspberry Pi over TeamViewer, mainly for the purpose of the video. So it's hard to run OBS on the Raspberry Pi while you're doing other things. TeamViewer also takes up a lot of memory, so it would be much better to have the Raspberry Pi attached directly to a monitor with a keyboard and mouse plugged in, but it's going to run on TeamViewer right now, so maybe give it a shot if you want. Okay, so here we are. we connect the Raspberry Pi. However your preferred method is. Let me go ahead and remove this. That was me running a test of it. Okay, so the first thing we're going to do is that we're going to go ahead and download the GitHub repository that we're using for this project. And it's going to kind of get us going. Okay, so here we are in the browser on Raspberry Pi. And we've gone to this PiFace GitHub repository. Now what we're going to do here is that we're going to go ahead and download the code. So we'll click on this green button and download zip. Then we're going to click on the up arrow and go show in folder. This is going to take us to our downloads area. And just going to go ahead and re-download it so I don't get a copy. Should be more prepared here. All right, so we're going to go ahead and download it again. Oops, download. And once it downloads, which should be pretty quick, we're going to right-click and go extract here. And then we're going to move the repository out onto the desktop. It's not really a repository at this point, it's just a folder with the files in it. Okay, and then on the front page of the repository, the README has a bunch of instructions on it. So, so let's go ahead and take a look at those instructions. So the first thing that we're going to do here is we're just going to kind of follow these down. So we've physically connected the camera to the Raspberry Pi already. We're going to go ahead and make sure the Raspberry Pi is turned on, or the camera is set up to be read into the Raspberry Pi. So we're going to go to Raspberry menu, Preferences, Raspberry Pi Configuration. And then we're going to go to Interfaces, and we're going to make sure that camera says enabled. If you switch it from disabled to enabled, you want to go ahead and reboot. Okay, which we don't need to do here. The next thing that we're going to do is that we're going to change the size of the swap file. So the swap file is basically, if your computer doesn't have enough RAM, if it runs out of RAM, the operating system will start to use the hard drive as RAM. Okay, so that's what a swap file is. Now, as computers have gotten more and more RAM, they use swap files less and less. But because we're going to be using a large amount of RAM to install some of the software, we need to go ahead and increase the size of the swap file on the Raspberry Pi. So we're going to go ahead and open up the terminal. These code files, you should be able to just copy and paste these. So we're going to go ahead and select that. Control-C to copy. Okay, so in the browser, we're going to Control-C to copy. In the terminal, we'll Control-V to paste. So what we're doing here is we're saying sudo, it means run as the super user, so like super user do. Okay, so run as the super user. Now you have to be logged in as a person with sudo privileges, and I'm probably saying it incorrectly, so I say it's sudo, but say it how you want. So okay, so basically it says run as the super user because you need administrative privileges to edit the file we're going to edit. Nano is just a text editor in the terminal. And then this is the path of the browser. So dphys-swap file, that's the name of the file that we're editing. So we're going to go ahead and hit enter. And Nano starts up. So Nano is a program that just runs in the browser. Notice that I've already changed it. So we would go ahead and arrow down. It's a pretty small file. So the swap size, basically I already changed it to 2048 on this Raspberry Pi. Sorry about that. It's originally 100. So Yeah, change it to 2048. All right, the next thing we're going to do, so once we do that, let's say you're going to go ahead and Control X. So notice this is how you control Nano down here. So this Control X, let me just go ahead and change something just so Nano lets me save it correctly. So basically we're going to Control X to exit. It'll ask, hey, do you want to save the modified buffer? That means, do you want to write the changes to disk? And we do, so we do Shift Y. And then it says the file name to write. We just leave it as the default and hit enter. Okay, so now we've changed this swap file, this definition file for the size of our swap file. Now what we have to do is we're going to use the system control utility. So highlight Control C, click into the terminal, Control V. We're going to use the system control utility. This is kind of in the most recent versions of Ubuntu-based systems. This is used all over the place, so just kind of get used to it. So we're going to sudo, that means to run it as the super user. The program we're running is system CTL, like system control. And then we give commands to that. So then we're going to say restart, and then we give the name of the thing we want to restart. Like this will be a service that you want to restart. Okay, so that's what we're going to do. Hit enter, it restarts. Take a second. Okay, in the meantime, let's go ahead and move on. So basically, we've already downloaded and unzipped the repository. We moved the unzipped file to Raspberry Pi desktop. And now we're going to go ahead and we're going to install a bunch of stuff and kind of get the computer ready to run the facial recognition. So let's go ahead and do that. We're going to open PiFace Master. It's kind of surprising that didn't run more quickly there. By the way, if you're using TeamViewer, if you go to View, change it from Auto to Select to optimize speed, and you're going to have a much better time with it. Okay, so we're inside of the repository, and first thing we're going to do is go to this util file and take a look at the files here. So we have this, oops, it's hard to read the names on those, isn't it? Okay, so we basically have two files. We have this .sh file, this RPI underscore OpenCV underscore install .sh, and then simplecamtest.py. Okay, so those are the two files in there. And let's go ahead and take a look at this OpenCV install. It's not really an install, it's more like a script to install a bunch of stuff. So it literally is a shell script. So that .sh is a shell script. And all it is we could copy and paste all of these commands. So basically you could go in here, this is hashtag, and then this line is a comment. The rest of them though, you could just copy these one by one and paste them into the terminal. Okay, but instead of doing that, basically I've just collected a bunch of lines of shell commands and put them into one file called sh file. Sorry, it's a text file with an sh extension. And basically what we're going to do then is we're going to execute this inside the terminal. Okay, now in order to do that, we need to go ahead and make this file executable, okay, which I have not done in the repository. Okay. So what we need to do here is that in order to open up a terminal, if you notice here, we have this, our terminal right now is in the folder that's the home folder for the user. So we're at Pi at Raspberry Pi, so that's our username and then the computer name. So Pi is the username, Raspberry Pi is the computer name, colon, and then the path, okay? So our path right now, if we were to type ls for list and enter, basically we would get all the files that are in our home folder. So if you take a look here, basically if we go to, this is the root of the drive we're on. When we go home Pi, if I were to click on this, basically this is the exact same thing. Now I hit Control H to show us hidden files, but I can undo that. So basically this is what we see here. If you look at my ls listing, and then you look down at this /home/pi, this tilde right here is just shorthand for the home folder of the user we're logged into. All right. Now, if I go into desktop, you'll see we're now looking at the files on the desktop. If I open that up, now we're back to where we were before this util. Now I can either copy this, path, Control C, and I can go CD space Control V and then paste. I can change the directory to here, to this folder, by doing that. I can also, in some, this program that's running here is just a directory browsing program. But what I can do in the one that's installed in Raspberry Pi is I can right click on a folder and go to Open in Terminal. And what that does for us is it opens a terminal at the location that we just selected. So when we right clicked on Util, notice that now I'm at the home folder for my user, desktop, piface-master, and then Util. So I'm inside of this folder. So I'm right here, all right? So that's what we need. So we need to have a terminal open inside of this folder. So the next thing we're going to do is that we're going to set this sh file to be executable. Okay, so basically the easiest thing to do, I've noticed that I don't know if it's a glitch inside of that. I found that this file was being reported as executable, but then was giving me permission problems. So we're just going to do it in the terminal here. So you're going to copy this sudo chmod, I don't know how to say any of this because I don't discuss it much. So sudo means as a super user, chmod means to change or modify the permissions, plus X means to make something executable, and then this is the file that we're chmodding. So we're chmodding or chmodding, I really don't know how to say it, this file to be executable. So go ahead and hit enter on that, and now it's executable. Okay, so now when we execute the file, it will run. But what are we executing? So before you run something like this, you definitely don't want to know what you're doing. So let's go ahead and open it. Now notice when I double click it now, it gives me the option. So now it's executable. Do I execute internal, open, or cancel? We just want to see it in a text editor, so we're going to click open. And here we have it. So basically the top portion of this is all, notice they all start with sudo apt, right? Oh, that is an error right there. Oh, I'm glad I looked at it because I accidentally typed in that sudo apt, would have given us a problem there. Okay, so notice that all the lines all the way down to here start with sudo space apt. So remember that's our saying, hey, run this as a super user. Apt is the program that installs software on Ubuntu or Debian-based systems, with Ubuntu being the most common. Then I believe Raspberry Pi is a derivative of Ubuntu or Debian. Either way, we use apt to install things. Okay, and then basically that automatically gets software from the repositories for the correct version of our OS. Okay. So basically, the first thing we're going to do is we're going to remove a couple pieces of software. You're going to get rid of LibreOffice and Wolfram Evrange. This is just to try to free up some space on your Raspberry Pi. Then we're going to clean and auto remove. So that basically just cleans up the installed software. Then we're going to update. This is a common sudo apt update, and sudo apt upgrade means that we're going to go say, hey apt, go get us all of the updated versions of all the software we have installed. And then we're going to say, hey apt, update everything that should be upgraded. Okay, so that gets us up to the point where everything should be current, like we cleaned it up and it's current. Then we're going to install a bunch of stuff. Okay, so these are all things that we need to make our facial recognition run. We're going to be using the OpenCV. We're going to be using OpenCV. With OpenCV, we need to. Oh, just one second here. With OpenCV, what we're going to need to do is that OpenCV has to be actually compiled on the Raspberry Pi. And the version you're going to download is actually going to be in a different order. So basically, between here and here, basically you are going to, actually, you know what, let's So this is what it's going to look like when you download it. So, okay, so this area right here is basically us installing OpenCV and compiling it on the computer. This is going to take like 2 hours to run. Okay, so this first part is going to take like 10 minutes. This next part may take like 2 hours. I suggest you leave it like overnight. If your Raspberry Pi freezes, don't unplug it. Just let it run for a minimum of 2 hours. Okay. Yeah, if it freezes up and you don't know if it's done or not, let it keep running for at least 2 hours. Okay. Then this last part, I wanted to do this without a virtual environment. I couldn't do it. So mainly because of the fact this OpenCV-contrib-Python, that's like what we need to run OpenCV inside our Python code. Apparently that has to be set up inside of a virtual environment. It gave me errors when I tried to not do that. So all a virtual environment is it's just a folder. So basically when we create a virtual environment, it just means that we're not going to use the Python installation for the computer. We're going to get a whole Python installation inside of a folder. This folder, the folder that we're going to install to is this home. It's going to be on our desktop called PyFace Virtual Environment. Okay, but that means that whenever we want to run anything, as far as our facial recognition programs go, we have to type this into you can copy and paste it, but we have to put this into the browser first to activate the virtual directory, or sorry, the virtual environment. And it's just something you get used to working in Python. For new users, it's a little bit complicated. All it is, it's a folder. That's basically what it is. People say virtual environment and it sounds really complicated. It's a folder. Okay, so basically you just put a Python installation inside of a folder, you activate it inside of your terminal with this source. There's a few different ways to activate it. This is my favorite way. So source, and then you just basically point it to whatever the virtual environment path is. In this case, that's the path right there, and then bin activate. And then once you do that, everything that you install, so then this next part is, hey, now that we've activated the virtual environment, we're going to install stuff. Pip is the way that you install things into a Python installation, in this case, a virtual environment. We're going to install NumPy, Pillow, then we're going to upgrade pip wheels and setup tools, and then we're going to finally install this OpenCV-contrib-Python. One thing that has been written on the GitHub for OpenCV is that basically you don't want to install multiple versions of this OpenCV. So you don't install both OpenCV-Python and OpenCV-contrib-Python, just install one or the other. Okay, I will work out whether this has to be done first or second. I'd rather do it second. I'd rather have the virtual environment all the way done before you try to install this. But it's safer to have it in OpenCV in before you install it, this OpenCV-contrib. So once again, this part is going to take 2 hours. Okay, so if you want to delete it first and then run it, yeah, anyway, just run the whole thing like I'm going to show you. So, okay, all right, so let's go ahead and do that. So for me, I've already installed OpenCV on this machine. If I ran it right now, it would just take a really long time. Okay, if it runs and it breaks, okay, so if you run this and it freezes your computer, you let it sit 2 hours, maybe overnight. When you come back, just delete this portion out of this this install.sh, RPI underscore OpenCV underscore install.sh, and then run it again without this portion. Okay, so if OpenCV installs, you can just run the whole thing again. And basically we'll get you that virtual environment. So there you go. All right, so I'm going to go ahead and remove this so that we can go ahead and run it. And remember, I've run this before, so it's going to be like a lot quicker on mine. Okay, so there is our install script. So let's go ahead and run it. So the next thing we're going to do, this ./ this is kind of a throwback. So basically, the period means to run something. But on Debian and on Ubuntu and on previous versions, you couldn't run any file without first giving it a directory. So basically this means, yeah, you're basically giving it a directory with the period / So, okay, so that's how you run things. Period / and then the name of the executable file. So let's go ahead and run it. Okay, we type it in, hit enter. And basically what you're going to see this do on this Raspberry Pi is this has already been run. So all the installations are already done, which makes it just go a lot faster. So because basically it's just going to run through and not need to do much at the beginning here. So okay, so now we're up to this apt upgrade. Okay, so let's just keep track of kind of where we're at here. So basically remember that I took out the OpenCV install chunk of code. So basically we are to, we just did auto remove, now it's doing the apt update. Okay, then it did apt upgrade. Now we're on to this, the pip3. Okay, so it says, hey, virtual env is already installed. Okay, that's great. Okay, so now we're in this section right here. Basically, it's creating the virtual environment. Notice it's a Python 3 virtual environment. And we're creating it on the desktop. You can see that the folder has already been created on our desktop right here. Now it's installing NumPy and Pillow, so we're down to right here. Okay, so it's installed NumPy and Pillow, and this right into our virtual environment. It's double checking pip wheel and setup tools. May not be necessary, to be honest with you. Okay, so now it's going to go ahead and start to install the actual OpenCV, which is what the software we're going to use for the facial recognition. Basically, have to download again. Okay, so at this point we have installed OpenCV. So basically, this video I ran the install script without actually compiling and installing OpenCV. Remember that you have to let it run for a really long time. Even if the Raspberry Pi becomes non-responsive, just let it run for like so. That happens. And it's best not to have it on TeamViewer or some other remote connection. It's best just to have it up to it. Okay, so let's go ahead and continue on here. So the next thing that we're going to do to ensure that we are have everything installed correctly, we're going to go ahead and run this simple cam test. So once again, we're going to go ahead and open the terminal. I always forget that it's a single click in Raspberry Pi, not a double click. All right, so basically what we're going to do is we're going to CD, so I'm going to control copy the path to our folder. Terminal, I'm going to go CD and then control shift V to paste into the terminal. Enter. Now our path looks correct. We're in this util. And then we're going to go ahead and, so to run all the commands in here, remember that we're using a virtual environment. Now there's a couple ways to do this, okay? The easiest way is just to tell it where the Python is. So basically if we type Python and then the name of the script, simplecam pi, right? Name and copy. Okay, Shift V. Okay, so if we were just to do this right now, we wouldn't be using our virtual environment. Right? We would just be using the Python installation on the computer. And how you know which Python you're going to be using, if you just type in which Python. Okay, so notice that the Python we're using is in user bin Python. Okay. So what we want to do is we want to start using our virtual environment. And how we're going to do that if we go in, let's take a look at our virtual environment. So we can do it a couple different ways. If we want to use our virtual environment, we can do a couple different ways. Okay. The easiest way is to probably just go into our virtual environment. Notice I just opened the PyFace virtual environment right here. I went into the bin, and basically I went into Python. And I can just right click on the Python file, like the the shortcut to the executable here, and I can just right click into the I can just go to the terminal and Control Shift V, and I can just paste in the path to that Python. There we go. Okay, so you can just specify which Python, and then basically this Python will use the environment closest to it. So this Python, because it's in the virtual environment, it will use the installed packages closest to it, like relative to it. So that's probably the easiest way to do it, right? Is just basically to just go find the file, specify which Python you want to run it on. And this saves a lot of time. And in the case of all your Python scripts, you can just put the top of the file exactly which Python you want them to run on also. But this is kind of a way just to point terminal. Okay, so basically we say, hey, go use this Python that's at this address, right? So go use this Python executable. That's where we installed everything into our virtual environment, right? And so that will work. Okay, so here's our PyTest. Oh, look, me. So, okay, so our PyTest worked. Is that old man in the ceiling? All right, so close it as soon as. Oh, so so what's happening with this test? I try to close the window. So basically, this will keep these two windows open until you stop it running. So how you're going to stop it running is you're going to Control C is the shortcut in the terminal to stop something. So basically, it will just keep running. It will even if you try to close the windows, it will just open them right back up until you Control C and stop running the program. Okay. So the next thing we're going to do here is that, so in that case, we just went and found the Python that we wanted to use. It's inside our virtual environment. We can just specify it like that. We can say, hey, use this specific Python installation on the computer. It will use the closest set of packages that are installed, in this case in our virtual environment. It's very simple. Now, if you don't want to do that every time, what you can do is you can use the source command. So you can go source and basically watch what's going to happen here. So this source command, and there are a few different ways to do this. I think this is the most straightforward. Basically, what we're going to do is we go into the bin folder of our virtual environment, and it's this activate folder, activate file here. So we're going to copy path, and basically we're going to go source, and then we have the path to our virtual environment, and then /bin / activate. Enter. And notice what happens now is that now everything that we're typing in is relative to our virtual environment. This is really confusing for people starting out though. Okay, this idea of virtual environments, it's just a folder with a Python installation in it. That's all it is. And then basically there's a way to make everything that you're running in the terminal relative to that environment, or basically use that environment that you specified. So the reason why this makes it a little bit more simple is now we don't have to specify the Python. We've already specified it by going into this virtual environment. So now if we, so I just highlighted this Python, I, Control C, Control V. I copied the return. Well, that's why it just ran. Okay, so now we do run the simple PyCam test again. It works great inside of our virtual environment. So if you're going to run a lot of commands and or you have a small screen, maybe it's better. But virtual environments are needlessly complicated a lot of times. So, but they're really super duper useful. So the reason why you need a virtual environment is that all these different projects have different requirements as far as software. In fact, they'll have like, one project will need some certain version of a certain library, another project will need a different version. In this way, it's not practical to have a single Python installation on a computer that's running multiple projects. You kind of need this virtual environment. So once we're in here, we can deactivate the virtual environment just by closing the terminal and then opening a new one. We can also just type in deactivate. Okay, and that's a basic virtual environment. It's a folder with Python executable and the packages that we installed on it. It's sometimes a lot easier just to source the virtual environment so that everything you're doing is inside the virtual environment, including like pip installs and stuff like that. Okay, so enough about virtual environments. So we've tested our so now with that simple PyCam test, if that runs, we're all set. All right, so basically if that runs, we're ready to start doing our facial recognition. So if we open up PyFace Master here and we go into face detection, all of these scripts will run in the same way that I'm about to describe to you. We are only going to go through, so this face detection, smile detection, all of these will run, but we're just going to run through building the facial recognition. Okay, so we already had these open. So let's take a look at the first one here. So we're going to run these in order. So in the first one, we build a data set. In the second one, we build a classifier. And in the third script, we run that classifier to actually identify people in the video feed. All right, so here we go. So I'm going to go ahead and source activate. I'm clicking up in my terminal to get like a history. You can also search your history. If you Control R, just type in source, right? So I can search the history. There I get my source, I can hit enter. So either way, up does a history of commands, and then Control R lets you search that history. Very, very, very useful. All right, so now that we're in that virtual environment, we can just type in Python. And this Python, remember we saw, was just a shortcut. It shortcuts to, in this case, Raspberry Pi installs Python 3.7. All right, so now we're going to go ahead and run the script. So we got face detection here. Python face detection, Control Shift V. Okay. Oops. And I'm in the wrong folder. Okay. So remember, if we look here, the mistake I just made is we're still in that util folder. So let's go ahead and copy the path to the folder, the facial recognition folder. Click into the terminal, CD, Control Shift V, and change the path. Now we're in that facial recognition folder. Now we're going to up arrow because we can do the same command just from this folder now. Now we're running the command Python and then that first script there. Okay, enter am integer. I mistyped integer, or am. I mistyped an. User ID and then press enter. So in this case, what's going to happen is this gets turned into a NumPy array later on, in the second script, maybe in this script. Yeah, in this script. So basically, the ID has to be a number of some kind. So just use an integer. In fact, it specifically converts it into an integer script. So use an integer. In this case, I'm going to use a 0. So 0 is my user ID. And by the way, this right here is just in the script here. So there's that will correct in the GitHub repository. So okay, so we're going to go ahead and hit enter 0 and enter. All right, initializing face capture. Look at the camera and wait. Okay, so there's me. I'm going to kind of get up close, kind of turn a little bit, kind of up, down. It's capturing, capturing, capturing. Okay, and when it's done, it will just finish. All right. So what has happened here is that the script created in this facial recognition folder, it created this data set. So basically, it took 30 pictures of me. So if we open this, if we go ahead and open this up, notice that it kind of cropped to the face itself. Some pretty odd photos because I was talking at the same time. All right, so yeah, so basically just took 30 photos, saved them to this data set. Notice that it's a simple way of saving it. So we saved it in user period, user ID period, and then the number, right? So user one would be user.1.1, right? Okay, so there we have it. There's the data set. So if you actually use this on a lot of different people, you would not want to delete this data set folder, right? Sure. So yeah, just be careful. All right, so now we're going to go ahead and we're going to run the second step. And now we're going to train the classifier. So basically what we're going to run now is we're going to run this OpenCV. We're using this LBPH face recognizer create and then cascade classifier. And then this is basically the definition of which classifier we're going to use. And then, yeah, there's a couple things we'll go through. Script. It's pretty straightforward. Okay, so next thing, so we're going to, I could have just typed, probably easier. So Python, name of the script. We're still in this facial recognition folder. We're going to hit enter, and now OpenCV is going to train. So notice that now the trainer data, the trainer folder is here. It ran really quite quickly. It's amazing that it can classifier that quick. Okay, and now finally, we're going to run this facial recognition script. Okay, so now notice that that I have kind of messed up here. So his name is Frank. Oh, so basically what we have here is that the user ID matches the index in this list. Now, there's a lot of different ways that this could get done, right? So this is a very simple way of doing it. Just writing, hard coding this list of names into a script as a list is just very, very, very simplistic, but as a minimal example, I think it works pretty well. Okay, so let's go ahead and do that. So my name should come up now as user 0. None is user 1, right? So these indices it's a 0-based index, right? So in a list, this is position 0, this is position 1. It's a list that starts. So if we were to refer to this list, names 0 would be Frank, names 1 would be none. Okay, so let's go ahead and run this. And we should see a box with my name on it. On space. Copied the path. We could run this so we could copy the whole path. Okay, so here is, oh, look at that. So basically, the facial recognition is running. There's me. There is not me. This one is unknown. Okay. Oh, wow. It's very interesting. Linus Torvald is it's listed as me. Okay, so let's see here. Oh, unknown. All right, so okay, so if we had more people in the database, I'm sure that it would work. In fact, let's go ahead and try this. Probably just make the video as quick as possible, but it's pretty interesting. So okay, so let's go ahead and run it again and see if we can get a better result here. So we're going to go ahead and run a data set, and this time we're going to create a second person. Okay, and this time it's going to be 1. So let's do. Okay. Now we're going to have to, each time you add a person, you have to run the face training, the trainer again. You can also add a number of faces and then run the trainer, right? So you could basically add all of your people running the first script, then run the trainer, and then run the classifier. Person. All right. So let's see. Notice it's kind of confusing here. Okay, so let's see if it functions. Okay, so there we have it. There we go. Okay. All right, guys. So so that is it. So that at that point your facial recognition should be running. Best of luck.